Rich.
Grace.
Steve.
Anna.
Dawn.
Imagine trying to read a book when the letters seem to shift positions. They make every single sentence a puzzle. Think about how frustrating this would be. This is a common experience for many with dyslexia. Today, I'm going to build off my last speech by diving into the brain's structure to uncover how dyslexia works neurologically, proving that it's difference in brain function and not a lack of effort. The first main point that I'm going to talk about is the structural brain differences. Research shows that individuals with dyslexia often exhibit reduced gray matter in the left hemisphere of the brain. This area is responsible for language processing. This hemisphere includes areas like the left tempoparietal cortex, crucial for phonological processing, which is heavily linked to reading. According to Guinevere Eden, these structural differences can impede the development of efficient reading skills. On top of that, studies have shown abnormalities in the planum temporale, a brain region involved in language comprehension. In typical readers, this area is asymmetrical, but in dyslexic individuals, it tends to be more symmetrical. This symmetry contributes to difficulties in processing written language. And those are just the tip of the iceberg. There are plenty more differences in brain anatomy. Another clear difference is that brains with dyslexia have been linked with reduced white matter counts. White matter is essentially the messenger fibers of the brain. These pathways often connect language processing regions. With reduced levels of white matter, the brain has to work extra hard and less efficiently to be able to read. This fact is supported by Malik Vandermosten's research, where he reaffirms disruptions in white matter can affect the coordination between speech production and comprehension. While they are still able to read, people with dyslexia and these connectivity issues can hinder the rapid transfer of information necessary for fluent reading. Now that we know about the physical differences in dyslexia, we can now examine how these differences truly affect brain functions during reading tasks. Brain imaging shows that due to these structural differences, dyslexia individuals adjust and use different neural pathways when they read, which affects reading efficiency and fluency. MRI studies reveal that dyslexic individuals show less activation in the left hemisphere's reading network. This includes the inferior frontal gyrus, parietal temporal, and occipital memoral regions. These areas are essential for decoding and recognizing written words. This is where my visual aspect comes into effect. This is just a graph of the areas that are activated when people with dyslexia are reading and those without dyslexia. As you can see, the dyslexic brain is all pretty centralized into one area, and the other has it firing through multiple different areas. Here's a more in-depth image. It's an actual MRI that shows the electrical signals that are being sent at the time of reading. As you can see, the non-dyslexic brain kind of splits up the responsibilities to many different areas of the brain, which allows it to be more efficient. This is further proven by researchers Sally Shaywitz and Bennett Shaywitz, who state that activation in the right hemisphere and frontal regions suggests that dyslexic readers may rely on alternative neural pathways. Such compensatory mechanisms, while helpful, are often less efficient. The reliance on non-traditional reading strategies highlight the importance of early detection and support. Specialized interventions can help in sort of rewiring the brain in order to develop more efficient reading strategies. Now that we know about both structural and functional brain differences, we can now explore how this knowledge can be used to find more effective educational interventions. The first thing I want to emphasize is the importance of early intervention. Neuroimaging can identify dyslexic brains even before children start reading. Early detection allows for early support. This early support can save kids from lots of frustration, stress, and anxiety. As John Gabrielli explains, children at risk for dyslexia can be identified before they fail, and intervention may be more successful when applied earlier. But what forms of support exist for these children? Structured literacy programs like the Orton-Gillingham approach have shown plenty of success. Ahern suggests this method of multisensory, sequential, and phonics-based helping helps students form stronger connections between letters and sounds. I'm not going to get completely in depth with all the plenty of different ones because there varies the level of effectiveness, and it kind of really just depends on the severity of the dyslexia in the student. In conclusion, dyslexia stems from specific neurological structures and functions, affecting how individuals process written language. By examining structural differences, activity patterns, and their implications for education, we as an audience hopefully can better understand this condition in those who have been diagnosed with it. Recognizing dyslexia as a scientific neurological difference allows teachers, parents, and other students to provide support and encouragement to those with the condition instead of jumping to conclusions that the student is lazy or unable to learn. Through education in the neurological background of dyslexia, we move towards a more understanding and empathetic society, where every student's learning is respected and supported. Thank you.